So this is the empirical rule in 5 minutes or less. The first thing that you want to understand is that if you were to plot all your data and all the frequencies and put that on this x-axis here, remember x is our observations, then that would be 100% of your data, right? The second thing that you want to remember is that the empirical rule only applies to symmetrical data. Now I'm going to bring this up here because let's just remember the data has to be symmetrical. If it's symmetrical, then that means if I folded this piece of paper right in the center, exactly half would be to the left and exactly half would be to the right. So what's a half of 100%? 50% to the left, 50% to the right. Now, here's a third tip for you. You see that the mean is located in the middle, and that's, by definition, symmetrical data because the mean equals the median equals the mode. So the definition of symmetrical data means that the mean is equal to the median is equal to the mode. So it's dead center here. So if you look at these percentages and you realize that this 68% doesn't go for just one standard deviation but actually starts at -1 standard deviation and goes all the way over here to +1 standard deviation, then what is the distance from the mean to +1 standard deviations? Well, it would be half of this, wouldn't it? Or 34%? Okay, so keep in mind this symmetrical concept that all the data is 100%, that half to the right from the mean is 50, half to the left of the mean is 50, from the mean to +1 is half of this, 34, to the mean to -1 is half of this, or 34. So now the question becomes, so what's left over? Well, let's pretend that instead of 99.72% that this is just 99%. So as we're talking about 3 standard deviations, it goes from -3, 99% later, to +3 standard deviations. Well, how much then is left over? In other words, not included within the 3 standard deviations. That would be 1%. Because all the data is 100%, so if 99% spans from -3 to +3, then 1% is left over. Now here's the next question. How much of that 1% is to the right? Half of it, because everything is symmetrical. So if this 99% is perfectly balanced across the mean, then 1% divided by 2, so 0.5% this way, 0.5% that way. So you see how if I keep in mind that all the data is 100% and that this is symmetrical, so if I folded this graph right here at the mean, that it divides all the numbers in half, including the 100%, then I can start to figure out different pieces under the graph simply by subtracting or adding based on what I know. Okay, so well, let me do this. I will leave you with this question. If I know that 100% is all of the data and 68% is just this middle part of the data, then how much is outside of the 68%? Well, do this very quickly here because I'm running out of time. 100% minus 68% is equal to 32%. So how much of that 32% that's outside of one standard deviation is to the right? Well, it would be half of that, wouldn't it? Or in other words, 16% is to the right and 16% is to the left. Okay, I hope that helps with the empirical rule. Keep in mind that it's symmetry and it's symmetrical about the mean, and the whole data is 100%. And then you have these percentages.